All right, let's dive in. Today, we're going to break down one of the absolute cornerstones of data science and machine learning, linear regression. It might sound a little technical, but trust me, it's simple, it's incredibly powerful, and it's the perfect place to start if you want to understand how machines can learn to predict the future. So let's get into it.
You know, when you strip it all away, so much of data science is just about trying to answer a very human question. How can we use the stuff we know right now to make a really good guess about what's going to happen next?
And a great way to start doing that is by asking this really simple but honestly super powerful question. We're essentially on the hunt for relationships, for patterns. If we see one thing move, how does that nudge something else?
Okay, let's make that totally real for a second. Think about this. We all have a gut feeling about it. As a house gets bigger, what do you naturally expect to happen to the price? It goes up, right? Well, that's exactly the kind of relationship linear regression was born to figure out.
So, if the problem is figuring out how two things are connected, what's the solution? Well, for a ton of real-world problems, the answer is a straight line. So let's meet the tool that draws that line for us. And here it is. The name pretty much gives the game away. Linear because, well, it uses a straight line. And regression is just a fancy word we use when we're trying to predict a number that can have a range of values, like a price or a temperature, instead of just a simple yes or no. It's all about finding the single best straight line to describe the data you've got. Now, I know what you're thinking. Simple. But seriously, do not let that word fool you. This algorithm is an absolute workhorse because it's so easy to understand and the results are so clear. It gets used everywhere. It's almost always the very first thing a data scientist will try on a new problem.
Okay, so how do we actually describe this magic line? We use a pretty simple equation. And hey, don't worry, this isn't going to be some scary math class, I promise. The best way to think about this equation is like it's a blueprint or maybe a recipe for making our predictions.
This table lays it all out for us, nice and neat. So Y is what we want to predict, our predicted house price. And X is the clue we have, the size of the house. Now, the two most important parts, the real rock stars, are beta 0 and beta 1. Beta 0, the intercept, is kind of like the base price of any house. And beta 1, the slope, tells us exactly how much the price goes up for every single extra square foot.
Let's just zoom in on those two for a second. The intercept is our starting point. Think of it like this. If you had a house with 0 square feet, which is impossible, I know, this is what the model would say it's worth. It's the base value. The slope, on the other hand, well, that's the engine. That's the part that does all the work. It's the number that says, okay, for every 1 unit bigger you make the house, you add this much to the price.
So here's the million-dollar question. How does the computer find the perfect values for that base price and that price per square foot? This is the learning in machine learning. It's all about a process of finding the one single best possible line to fit all of our data points.
And the goal is actually really intuitive. It's just to draw a line through our data that's as close to all the points as it can possibly be. We measure the error by looking at the gap between each real house price and the price our line predicted for it. The best line is simply the one that makes the grand total of all those little gaps as small as humanly or machinely possible.
And this is basically how it does it. First, we just plot out all the data we have. Second, the model takes a guess, it just draws a line. Third, and this is the crucial part, it measures how wrong it was. It adds up all the errors. And finally, it just nudges the line a little bit, changes the slope or the starting point, and it checks the error again. It just keeps repeating that process over and over until it can't make the error any smaller. And boom, that's learning. Okay, so we get the theory. We know how it works. Now, let's talk about the real world. Where is this thing actually used? And, just as important, what are the rules? When should you not use it?
You will see this thing absolutely everywhere. We've been talking about house prices, but businesses use it constantly to estimate how their sales might change based on what they spend on ads or to forecast demand for a new product. Sometimes it's just a fantastic tool for getting a quick, clear understanding of how two things are related in your data.
So far, we've only used one piece of information, the house size, to predict the price. That's called simple linear regression. But what if you have more clues? What if you also know the number of bedrooms or how old the house is? Well, you can use all of them. And when you do, that's called multiple linear regression. It's just a way to make our predictions even smarter and more accurate.
But look, no tool is perfect, right? And it's super important to know the limitations. Its biggest weakness is right there in the name, linear. If the real pattern in your data is a curve, trying to fit a straight line to it is, well, it's not going to work out very well. It's also really sensitive to outliers, those extreme data points. Imagine one gigantic mansion in a neighborhood of tiny bungalows. That one house could pull the whole line out of whack.
And this really gets to the heart of it. You just have to know this stuff. It's like trying to become a professional chef without knowing how to properly use a knife. It's that foundational, that essential for anyone who's serious about data science or machine learning. So really, the key takeaway here is that linear regression is the starting block. It's the foundation upon which so many other, more complicated ideas are built. Once you really understand how to model a relationship with a simple line, you're basically ready to start tackling the more advanced stuff.
And that kind of leaves us with a fun question to think about, doesn't it? We've just mastered the art of making predictions with a straight line. But what do you do when the world isn't straight? What happens when the real patterns are messy and they curve and they twist? Well, that is a fantastic question for next time. Thanks so much for watching.